That works. Cool. So, hi, I'm Andrew. I've been migrating a bunch of stuff from CMake to Bazel, as he just lovely said. And this is kind of a continuation of a talk that was given last year from my colleagues Luca and Gabriel, as they were talking about migrating the Android client over to Bazel from Gradle. So we're going to go over a little bit of the technical aspects of how we actually performed the migration, and then talk a little bit about the platform challenges that we had as well. Hopefully there'll be some lessons and takeaways throughout for any of you who are also looking to do some form of a CMake to Windows Bazel migration. And yes, Windows will be involved in the platform's challenges, oddly. So a little bit of context, a little bit of lay of the land. We've got the Android and the iOS clients. They're currently already in Bazel by the time that we kind of start this migration in 2023. All of these clients rely on some kind of shared functionality that's written in C++ in a different repo that's also constructed with CMake. So we kind of can't remove CMake just from the desktop clients. We kind of have to go through everything. And so these desktop clients is just C++ with a whole bunch of TypeScript on top, but we're focusing on the C++. And we've got a number of different platforms to consider for the desktop, right? We've got Windows, we've got Mac OS, and we've got Linux. We've got a bunch of architectures like x86, 64, ARM64, technically x86 as well at one point, but and then we've also got to think about a dozen like different deliveries that we need to make to like Epic Game Store, Windows Store, Snap, Debian, and all sorts. In terms of size, we've got like 4,200 different targets, give or take a few for like different platforms that need maybe a few extra helpers or a few less. And just about 2,800 of those come directly from this core repository. So it's a lot happening down in that one repository. We pull that in via a submodule, which will become important in a little bit for a problem. So you might be asking why? Why migrate over to Bazel? We've got a build system that's been working for a number of years, pushing out desktop clients pretty regularly. But really, as we're scaling up to the point where we're having hundreds of PRs, hundreds of builds, we really want to be able to cache a lot of the actions between C++. And CMake doesn't really have a native way of doing that. And there are things like Ccache and SCcache, but SCcache we found, I think, to be a little bit fiddly with like sharing across network, and Ccache is just local to that agent. So even though things could be, for example, rebuilt, it could be built once, it has to propagate through all the agents. We've also got tons of different languages, which is perfect for Bazel, right? It's just one place to run all of our Java, Kotlin, Objective-C, protobuf, generated code, all sorts. So that also makes it a perfect fit. And then finally, we do want to bring it into a monorepo. We want to be able to have our users just type one thing and get an iOS client or an Android client out, right? So good reasons to use Bazel. And then in terms of time, I like to look back and see like how do these things start, because they generally, these sorts of migrations don't go very fast. So I looked back and found that there was a commit in this core repository that went back to 2016, just obviously about a year after Bazel actually was released for the first time. So people were already thinking back already in 2016 about how to do this. And I think it was about 2020, 2021, we actually went more full steam ahead across all of our clients. 2023, as I mentioned, end of that, like October, we actually started to migrate things from the desktop side. And then, as you can see at the bottom there, May of this year is when we actually managed to finally remove CMake. So all in all, about 9 years, which is just a little bit of time. And of course, over this time, we've got to have some goals for this gigantic project, right? So we've got to be incremental. We have to make sure that when we're moving from CMake to Bazel, we're doing it in a slow way, because we sadly don't have the ability to just say, stop development for like 8 months and we'll change you over to Bazel. That's not going to happen. We also want this to be automated, because we really don't want to be messing around with parity between two different build systems, right, and maintaining those things. So they have to be done automatically if we can. And finally, CMake has to be the source of truth. It has to be, we have to keep up with CMake developments, new versions over this 9-year period. So we really just have to make sure that's the only place that we're touching. So getting into the weeds a little bit, we've got an example here of a pretty straightforward library in CMake, right? We've got some sources, they compose a music library, and that music library has a dependency on some MP3 playback. library somewhere else in the CMake graph. And at Spotify, we kind of abstracted this away, so our users don't touch those more base CMake functions. So we end up having this cadre of functions for like spadd library, spadd sources. So this is basically the same file, just now done in that sort of way of abstracting things out using CMake functions. And this lets us have a hell of a lot of like control, and we can start doing validation checking. So things like if you can specify a flag on a particular target, we can say, no, that's a deprecated flag. We don't want you to do that because that might impact our builds, or we know it's bad. We can also have things like options that set up debug defines for you, or things like that. And then, interestingly, we can even do like validating dependencies and kind of emulating, even in the CMake side when we were starting out, emulating a little bit of Bazel's visibility mechanics by saying, like, you can't see that target. You're not allowed. It churns a lot. You're not allowed to see it. And because this is applied to basically all of the targets in CMake that we actually care about at Spotify, this makes it an absolutely perfect place to start like writing out all of this information to some other representation. So we added a little function, SP export Bazel library, that really, it just takes advantage of CMake's very permissive configuration step, where you can mutate files, you can mutate the source tree if you want to, you can add templates, you can arbitrarily run processes, and we can just say, like, here's an intermediary plain text file. Just start writing out all the content, all of this context, where we are in CMake, its name, its sources, its dependencies, anything extra that we really want to know about, right? And from that, we get this nice, very simple key value pair system. We could have gone with a more like structured JSON YAML, but we found plain text to be pretty nice, pretty quick to kind of iterate on as well. And now that we have that to disk, we can again take advantage of the export process, the execute process in CMake to just run this medium-sized, I'm going to say medium-sized Python file that takes that plain text file, ingests it, creates an in-memory representation, does a bunch of transformations, and then writes all of the Bazel files for us. So this isn't using Gazelle or anything like that. And the transformations that this really has to do are things like obviously taking the CMake names, which have to be unique, and then mapping those to exactly where those build files are now on disk. As well as doing things like zlib might be something that we have as a submodule in our repository that we recurse into with CMake, but we don't necessarily want to have that represented in our plain text format, right? Because we maybe want to have a HTTP archive or a Git repo that represents this. We need to map that as well. And then finally, doing something like taking the shared library and saying, right, well, that's the macro that we're going to use when we actually want to compile these things. And so that really just covers the simpler side of, like, I say simple, taking these like CMake files and translating them into very nice, concise build files that we want to have. But that's really only half the battle, because then we obviously need to have these actual, we need to have the actual infrastructure to build those targets. And I would say luckily, but there's a lot of work from the community that is very wonderful. And the tools and the rule sets that were available got us up running very, very quickly, I would say. We still have some thin wrappers over the CC libraries, for example. But most of the time, it's just like a few tags, a few extra little bits, and you're fine, right? And then the vendor dependencies translated very, very well. So instead of having curl in the middle of a configuration step, execute, grab a HTTP archive, expand it out, recurse into that directory, we can just have HTTP archive instead. And then all of our subdirectory, all of our submodules in Git can just be removed and replaced with Git repositories. So that's very, very nice. We still obviously do need some manual build files for these HTTP archives and Git repositories, but those were few and far between, I would say. And obviously, there are some issues. It wasn't all just, rainbows. We found that some CMake concepts were starting to permeate over to Bazel, which is understandable considering we are going from a very CMake-orientated build system to Bazel, obviously. So the concepts like release, which don't live in Bazel were starting to permeate like the names of configs and things like that. So we squashed those pretty as soon as we could. We also found that we had a good couple of build files that were a little bit more of the esoteric variety, where things that either didn't fit into our SP prefixed functions, or they just needed a little bit more handcrafting on exactly how we're going to do this in a nice Bazel way, because they didn't map nicely. Maybe they had some kind of non-determinism in there because they were doing a specific action in a configuration step of CMake that we couldn't replicate in Bazel because Bazel would just not let you do that. And then finally, the way that we decided to go with our incremental approach meant that we had a lot of duplication of our builds. Basically, all of our CMake builds ended up having some analogous Bazel representation. We perhaps could have gone with a slower approach of removing a CMake build and then replacing with a Bazel one. But I think we really wanted that level of validation and like confirmation that everything was always working no matter what. And one big takeaway is that you have to configure everything in the CMake graph. You can no longer, oftentimes we optimize the configuration step when we have large CMake projects by perhaps saying, I'm on Linux, I don't really want an iOS helper, so I'm not going to add that target, I'm not going to visit a Linux directory because I'm on Windows. And when we're using CMake as this source of truth and trying to extract out the whole graph, we just can't be can't have partial graphs anymore. So we had to stay away from those sorts of mechanisms. And things like the top layer here about adding specific sources to our targets conditionally, that also had to be extracted and moved out so that we effectively always add those sources. And we, for this example, we were using preprocessor macros to basically blank out the entirety of the CMake file, the CPP file. But this will obviously have a massive impact on your CMake configuration times when you do it, because you're now visiting everything. And also it's good to know that this, because of all of your build files in Bazel are dependent on this particular part of the configuration step, you are going to have a 4 to 5 minute wait time for every Bazel process to begin, which is not ideal, but it felt very good when we finally removed the CMake section and saw all the graphs just shunt down by 5 minutes. It was a nice feeling. So the outcomes from this sort of a migration, I would say that thanks to like a lot of the automation that we had and the work that people had been doing for the years before we started looking at the desktop and migration, we managed to get things going very, very quickly. The macOS client came first. Basically, I think it was a month afterwards. We were listening to music from that. And then a month after that, so Christmas time, we managed to get the first Windows version as well, running and playing music. So it was a very, very quick affair, which was lovely. But obviously, just getting executables isn't the entire thing. There was a lot of validation that went in. We needed to effectively look at what we were doing in CMake, what were the rules getting us to do in Bazel, what were the differences? Why, for example, macOS had like binary p-lists, I believe, for their rules Mac, but we were doing plain text p-lists. So it was just validation of those little things of, is this okay? Do we need to make some changes? But then around, I think it was autumn of 2024, we actually started rolling out Windows builds and macOS builds that were built with Bazel, which was amazing that we managed to get this done so quickly with a lot of validation and a lot of packaging. But yeah, migration completed, which is very, very good. Woo. So let's talk about platforms and some of the issues that we encountered. Mac OS was the easiest to running, as I said. A lot of the time it was more down to getting the rules or figuring out what the rule sets wanted us to do. They were far less permissive. They were relying more on Apple guidelines, whereas perhaps the store didn't particularly care about some aspect of the guidelines. I think there was one example of versions, the way that we were applying versions in CMake was different to the way that the Bazel rule set enforced. So we needed to make sure that those things were in check, but ultimately it's very, very quick, very, very easy. Linux did have one oddity I remember, which was that we needed, in CMake you can often just call this pkg config and then ask the Linux system where this particular library is, what its linker flags that it needs and things like that. We replicated that with repository rules, and it felt wrong because obviously you're asking in a repository rule, like, where is this thing, and I'm going to then symlink it into the Bazel ecosystem. But it did work, and we ummed and ahed about it a lot. We thought about it, but because we're using Docker to abstract away a lot of the bare metal, the base CI agents and people's machines, we do kind of have a level of hermeticity that's okay, right? We've got this Docker container that changes very rarely, so these things are always going to exist in the same sort of way for all of these Bazel processes, which was nice. But Windows. So we found that there were, when we started getting further and further into Windows, and we started to look at, okay, we've got most of the stuff working, we've got an executable, right, let's have a look at the build speeds, are they comparable? And we found no, they were oddly not. We use a lot of Python to do a lot of our code generation. So each one of these proto-compiles effectively resolves into a Python execution for a plugin that we want to run. And we had 427 of these, plus maybe an extra 100 of different Python things running. And I worked it out. If we have 24 executors, these 427 things, each wonderfully, each one gets equally shared amongst all those executors. It's about 10 minutes of build time, just waiting for these proto-compiles to complete. And what we found was there was one flag, build Python zip, which defaults to on Windows and off on all other platforms. Lucky when your problems could be solved by one single flag. But what we think is that these executable zips, they are being unpacked on every single one of these executions, or every single action, and then the content of that is being thrown away, and you're redoing the zipping all over again. But so, luckily, because it's a straightforward flag, we can turn it off, and we got down to 1 second, which was much more in line with our macOS and Linux setups that we were having. But sad, and also that was also a good one for graph suddenly going very down from one single change, so it was very, very nice. But you'll notice that we've enabled run files there, and that is a bit of a problem, because Windows still sometimes encounters max path problems. For anyone who is unaware, and I'm envious that you aren't aware, and I'm sorry to break that, Windows does have a kind of 260 character limit for paths. That's not super straightforward. There have been lots of patches, lots of changes to it, and we've got long path support now in like Windows 10 and 11. So it isn't as straightforward as that. But we did hit 260 characters and more regularly during this migration. And it comes down to three kind of major factors. We have a very structured file system at Spotify. We want things to be like, here's a system, it's composed of entities like APIs and implementations, and those are reflected in the file system as well. But what we found is that oftentimes the names of these parts of directories can get repeated. So this is the length is real, but I have changed the words. But supplementary sessions, you get supplementary again because people like to alliterate or repeat these words. Secondly, because we're running from CMake to Bazel, as I said, all of the target names in CMake have to be unique. So you can't have a really nice short API, impl, Objective-C bindings. You have to be very, very unique. And so people oftentimes, the simplest way is to take the entity name, and that's now the target name. So now we have quite a lot of words repeated. And then finally, the major issue, another factor here is Docker. We do use it at the moment to kind of abstract away the agent, similar to Linux, so that we don't have to care about like the Visual Studio install, where it is, keeping it up to date, badgering the people that run the CI to like update those things and deal with conflicts. If people, for example, still need particular older versions of Visual Studio, we're not the only people using these agents, right? But what we found was that 8.3 name support couldn't be enabled on this container. And for those who aren't aware, 8.3 name support is basically where Windows can take this sort of a long part of a path, shorten it down using this tilde syntax. And then when you use that, Windows will be able to figure out, you meant supplementary sessions. We were just not able to enable this on containers. We tried in the Docker file, we tried while it was running, we tried prepending the command that we were going to run to be able to do this, and it just didn't work. And because of that, we ended up with having our exec root with the system and the entity name, and then the target, and then the system, and then the entity name, and then the target. And that's about 284 characters, which isn't even the longest that we've seen. We were having 300, 310, so yeah. And oftentimes you won't get a nice error that Windows says this path is too long. It will go, I can't find the file for you. And then you have to rip your hair out deciding, is this a Bazel problem and I've written the rule wrong? Or is this just Windows and it doesn't know what it's doing? And just for context, if 8.3 name support was enabled, it would be 150 characters, which is A-OK. And one extra thing that we ran into with this was because desktop is consuming this core repository via submodule, you have to also add the path for that submodule to every single time that you're doing something in the desktop land, which means that while it ran in core and built and was fine, as soon as you got bumped into the desktop environment, for example, it would break because we had an extra 24 characters that were being taken up by this submodule path. But as long as you're staying away from those factors, and you hopefully won't run into it, but if you do, you can kind of start guarding against it in the CMake stage. It's a very well structured, the run files is very well structured, so you can understand if this is a test and uses run files, I can kind of guess how long this path is going to be, and you can guard that in CMake before you even get to the Bazel stage. And you can also just rename targets. We got very creative. It's impressive how short you can make things if you want to. And then finally, this is my thing, like I would say you need to be aware if you have any very, very old tools that use maybe the old C-style array max path that's always going to be 260 characters. You're probably not going to have long path support with that no matter what you do. And then of course, follow the best practices on Bazel. They do work. We have, for example, in our Basilisk, in our tools Bazel wrapper, we make sure that the output user route is exactly what's said in the guidelines to be as short as possible. Every character really does count. And yeah, this was a number of the Windows things that we had. We ran into more, oddly, but these are the two ones that came most to mind when writing this presentation. And I'm around if you want to chat about Windows, and I'm sorry that you want to chat about Windows and Bazel, but yeah, cool. Any questions? There's a microphone there.
During the configure bit, you said that you had to avoid kind of conditional, kind of CMake library includes or something like that?
Yep.
Well, how do you handle situations where you have some libraries that will only build on certain like architectures or systems or similar?
You mean like if I had zlib and that only worked on Linux, for example?
Yes, something like that.
I don't believe that's a problem that we ran into, but I think that if we were to run into that sort of a problem, it would depend on how, if no one else had, because obviously at the end of this, you have to pick which platform is going to be the one that generates the final build files. And perhaps that could be Linux in your example.
Yeah, I mean, an example of where you run into this a bunch maybe is like in sort of UI type stuff. Yeah, where you're gonna get like sort of pretty wide differences in terms of how something might work on different operating systems.
Is this, you said, an external dependency, or is it internal to your code base?
It could be both. I mean,
external dependencies, we found that we could rely on like HTTP archive and Git repo and write those things ourselves. We left out the external dependencies from that because I think we would probably have run into that exact problem.
Okay,
right?
yeah, that makes sense. All right, thank you.
Oh, another question.
Thanks for the talk. My question is about unit tests and end-to-end tests. Typically, Bazel is very hermetic, so like if a test needs a resource or something, you need to be explicit, provide it so it can access it during runtime. Anything that you needed to do?
For end-to-end testing, I think our end-to-end testing, when it came to the C++ side of things, I don't remember running into issues with like resources being, do you mean resources in terms of like CPU and RAM, or do you mean like data files?
Data files.
I can have a look later and get back to you. I'm afraid I don't have an answer right now, but I think that those are probably the level of things where we would be doing like manual build files to manage things. Yep.
Hey, I was wondering if you use any open source components that need to have a CMake component remain for other external users, and how you would juggle having Bazel and CMake together, staying synchronous.
That's a great question, because there have been times where I've thought about or wanted to open source some things that we have like internally that CMake, and then we've converted over to Bazel. Those things, I think, if they're thin enough, if they're small enough, the maintenance cost of maintaining both isn't as heavy as like running the whole CMake graph. So I don't think we've had to open source anything just yet, but I know that I think we got Chromium embedded framework to start adding Bazel, so I can ask those people and see like what they think about like maintaining both, because I believe they still have CMake integration as well, but I could be wrong.
Hi, I had a question about the package config repository rule that you had up briefly. So normally when you run package config, it spits out some linker flags and some C flags for includes and link paths. And you mentioned that you were like symlinking the required files into some repository. Could you talk a little more about how are you picking which files? Like how granular are you with that? Are you just symlinking the entirety of user include and relying on the
No, I think we were pretty, I wrote this and I think I was pretty, what can I get away with? There were time constraints, so it was very much like, what is the minimum set of things that are required to make this build? I believe it was more like headers. I think I might have left out even some linkers. If things weren't relevant, I left them out as much as possible.
I guess what I'm asking is like, let's say you're trying to build zlib, and so the include paths are like used to include zlib. Are you just symlinking that entire directory into that repository and generating?
For PKG config?
Yeah.
I'm going to say probably yes. We are probably symlinking that entire directory in order to get things to work. There are other options like vendoring the whole directory and downloading it via HTTP archive. But given, as I said, given Docker, it was like, this is all right.
Okay, and then for the link flags, are you relying on the tool chain, just picking that up from the local paths? You're not like symlinking the actual shared object in or anything?
I think so, yes.
Okay, thanks.
I can double check though if you would like. Cool, I think I'm out of time. I'm being told I'm out of time. So thank you very much for listening. It's been a pleasure.